Another optimization problem. Suppose I'm given a wire that's 10 centimeters long. I'm going to cut the wire, then I'm going to form a circle and a square, and I want to find the place I should cut so that the area of the two objects, when I add them together, is maximized. I draw the picture. Here's my wire, 10 centimeters long. I want to make a cut. I'll name the place where I make the cut X. So on one side I have length X, on the other side I have 10 minus X. Let's turn the X piece into a circle. The 10 minus X piece is going to become a square. What are we trying to do now? I have square and a circle. I want largest area sum. So largest is saying that I'm going to maximize the area. Also, I'm going to need formulas for the area of a circle and a square. So let's take a look. Start with the circle. We're going to give the circle the piece X. Square will get 10 minus X. So the circumference of the circle is 2 pi r, which is also equal to X. I solve for r because I'll need that for the area. So r is equal to X over 2 pi. Then my area is pi r squared, or pi times X over 2 pi squared, or X squared over 4 pi. So that's my area of the circle. Let's take a look at the square. The 10 minus X is going to be the sum of the lengths of all the sides of the square. So one of these sides is going to be 10 minus X divided by 4. That's going to tell me the area of the square then is just base times height, or 10 minus X over 4 squared. We're going to add the two areas together. And that's going to be the function that I'm going to take my derivative of. We want to maximize this area function here. So we take the derivative, okay, so this 2x comes down, 2 comes down, 10 minus x over 4. We get a 1 exponent there, and I multiply by the derivative of the inside. Derivative of the inside is what's on the x, so it's going to give me a minus a quarter. I set that equal to 0. And for this one, since there's a pi floating around, turn everything into numbers, because it'll be a real pain to try to get a closed form with that pi floating around. So that's just going to give me 0.159x minus 1.25 plus 0.125x equals 0. When I solve for x, I get 4.4. I'm going to put that in my equation for area, and we see that the area that comes out adding these two together is going to give me 3.5. So I'm going to plot that on the graph of my area function. Okay, this is a of x. Now, let's see what else we have. What are the boundaries of our domain here? Well, let's take a look at the wire. What numbers can we let x be equal to? Well, if I refuse to cut at all, that would be the same as saying that x is equal to 0 if I go from this direction. Or if I go all the way out and refuse to cut, that's going to be giving everything to this side, meaning x is going to be equal to 10. Or in other words, if I let x be equal to 0, then I'm going to give everything to the square. If I let x be equal to 10, then I'm giving everything to the circle. So I'll plot those 2 points, x equal to 0, x equal to 10, and what do we notice? Well, these 2 points are going to give me numbers that are much bigger than my 3.5. We're going to get 6.25 if I just go with the square, 7.96 if I go with the circle. Okay, so that's going to mean a critical point not going to come into play. The critical point actually minimizes the area. So if I want to maximize the area, I want to go with all to the circle. Okay, we should finish off the graph just to check that we did the derivative right, at least check it by seeing that what we know about the graph is true. So if I take the derivative, evaluate at 1, I'm going to get 2 over 4 pi minus 18 over 6, which gives me roughly minus 1. So that's going to give me decreasing on this side of 4.4, since 1 is less than that. And then if I take 5, which is going to be on this side, we're going to get 0.171, which is positive, so we know it's increasing on this side. And my critical point is definitely a minimum. It's going from decreasing to increasing. So the answer It's going to be, okay, the problem tricked us. The maximizing won't be the critical point. It'll be an endpoint.